Alright, first thing we did was we reviewed some key things. We talked about, again, data and information. We talked about management and the levels. We're at the top level. It's going to use more summarized information, not as much, but more brought together to help them make some kind of decision. Same thing we talk about converting the data and information, moving it through to allow us to make decisions. We talked about this is bigger because there's more information being, transaction, so forth, feeding in and out of the database. Alright, and then we have the workforce down here, and we have the levels of management over here. Alright, the next thing. Creating an information system. We reviewed the whole step. Investigation. We talked about this the other day. Defining the problem or challenge, whatever. Analysis. Creating all the details. We talked about the loop back. Taking it back to the people in charge and seeing if what you see is the same as what they see before you start the design. It would be like the builder for the house would keep asking you, are you sure, in looking at the blueprints, before you even made the blueprints, okay, this is how much you want this is how much you want, how many bathrooms, so forth, this is what you need in the information system. Then we design it. We talked about that the other day. Flowcharts, pseudocode, all kinds of things. Get the design exactly how you want it, and then you start creating it. We're going to talk more specifically about that in a little bit. Implement it, evaluate and maintain. Find something that's wrong, you investigate the issue, analyze possible solutions, design a solution, develop that solution, implement it, evaluate, make sure the solution's working. Same thing with maintenance. This is all top-down design. We talked briefly about bottom-up design, creating a prototype and then building on it. Make changes and adjustments and build on it. Okay? Considered bottom-up. Most stats review. In that development stage, we draw an arrow over here and we talk about programming. Develop software, create apps. Purpose, usually we are solving either, you might call it a problem, a challenge, an opportunity. We're going to look at a way to use software to do something better than the way we're currently doing it, whether we're currently using software or doing it some other way. So we develop code. Code is what a human writes, and that code then is, later on we're going to talk about, converted into something the computer can use. So we're going to solve a problem, or like I talked about, a challenge, an opportunity. The first thing we have to do is you have to understand that. You have to know exactly what they want. You have to define it specifically. And once you know exactly what the problem is, then you can start working on specifications, all the details around understanding the problem. Once you have all those, now you can design what the solution is going to look like. You can make flowcharts that show the flow of things. You can use pseudocode, more English-like code that explains how the software will run. Then lots of feedback loops here, up here, to make sure you have it all correct before you move on. And we can write the code. Pick some particular language to write it in. It's referred to as the source code. So that code is written and then it's either compiled or interpreted. If it's compiled, it matches some operating system somewheres. Like you compile it to run on Windows, or you compile it to run on Linux, or iOS, or Android, or whatever you compile it to run on. Some software, instead of compiling, can be interpreted. It can be left in the source code form, and then every time it needs to be executed, the interpreter actually compiles it on the run. That's kind of a very simplistic way to explain that. If we compile it, we create an object code. The object code is linked with items from the library, and it creates then for us an executable code, which runs on the operating system, whatever operating system it was compiled for. Then we need to test, evaluate, fix, and recompile. Software all needs to be tested. We need to document it well. We design software that needs to be well documented. That happens at all the stages, everything you're doing. And then maintenance. Software always has patches or fixes, updates. A lot of them have to do with security, but could be anything. And then you run that through the process again, write the new code, update the software. And that is it for today.